Today's notes are on addition and subtraction of polynomials, and our objective is to do just that, add and subtract polynomials. Okay. Remember our work with expressions. An example of an expression would be 4x squared minus 3x plus 2y minus 8. Notice that there are 4 terms here, and that none of these terms are like terms. Okay. Remember that there's a difference in variable terms and constant terms. Our constant term here would be negative 8, whereas our variable terms here would be 4x squared, negative 3x, and 2y. Okay. Also remember what it means to be a coefficient. The coefficient is the numerical portion of the term. So 4 is a coefficient, negative 3 is a coefficient, and 2 is a coefficient. Okay. If you need a little refresher, okay, like terms have the same variable and exponent. In this particular example, none of these terms are like terms. Even though 4x squared and 3x both have x's, they don't have the same exponent. If it had been 4x squared minus 3x squared, then we would have like terms. Okay. All right, now polynomials are essentially variable expressions, but we classify them based on their number of terms. So this slide is a big vocabulary slide so that when I say terms later on, you know what I'm talking about. Okay. Monomials are a single term. So some examples would be 7x, 3x squared y to the 5th z, and 923q to the 15th. Those are all examples of monomials. Notice that they don't have any addition or subtraction involved in them, so they are a single term. Binomials have 2 terms, 3x plus 7, 5y cubed minus 9. Those are examples of binomials. They have 2 terms. 1 term, 2 terms. 1 term, 2 terms. Okay. Trinomials have 3 terms. Negative 2x squared plus 7x minus 4. They have 1, 2, 3 terms. Okay. Now, any polynomial that has more than 3 terms, they just get lumped together and they're just referred to as polynomials. So you'll often hear me say the words monomial, binomial, or trinomial. Those are specific types of polynomials based on the number of terms they have. Okay. Now, when we want to add or subtract polynomials, okay, we're going to add polynomials that are of the form ax to the n, where n is the degree, okay, and a is the coefficient. Okay, and we're going to typically write these polynomials in descending order, where we write the highest or the largest exponent first and then the lowest exponent last. Okay, so for example, negative 3 plus x we would typically write as x minus 3. Alright, so here's our first example. We want to add 2x squared plus 4x minus 3 and x squared minus 6x minus 2. Now with addition, we really can just ignore the parentheses. So we can rewrite this as 2x squared plus 4x minus 3 plus 6x minus 2. Okay. Now it might be helpful for you to rewrite the expression so that your like terms are next to each other, and the commutative property is what allows us to do that. So you could rewrite it as 2x squared plus x squared plus 4x minus 6x minus 3 minus 2. Now at that point you're just going to combine your like terms. Okay. 2x squared plus x squared would give us 3x squared. 4x minus 6x would give us negative 2x, and negative 3 minus 2 would give us negative 5. Now notice that when I combine those like terms, my variable and my exponent are not changing, only my coefficients are changing. So 2 plus 1, remember there's an invisible 1 in front of that x squared, gave me a 3. 4 minus 6 gave me a negative 2, and negative 3 minus 2 gave me a negative 5. Okay. Now, in the case of subtraction, before I can get rid of any of the parentheses, I have to distribute a negative 1. So right here, I'm going to think of this as a negative 1, and I'm going to distribute it. Now when I distribute that, I'm going to get a negative 2y squared minus 6y plus 1. Okay, so negative 1 times 2y squared gives me a negative 2y squared. Negative 1 times 6y gives me a negative 6y. And negative 1 times negative 1 gives me a positive 1. Okay, at that point I can drop off the parentheses, and then it becomes just like the previous problem we did. I can rearrange the terms if I want to so that all my like terms are together, and then I'll just combine my like terms. 3y squared minus 2y squared gives me a y squared. Negative 5y minus 6y gives me a negative 11y, and 7 plus 1 gives me 8. Okay. Here's one where I have addition and subtraction. Again, before I can do anything, I have to make sure that I take care of this negative 1 by distributing it. Okay. Once I distribute it, I can drop the parentheses, and I would end up with 4p squared minus 3p plus 1 plus 2p minus 2. None of that first part changed. It's only that part where I distributed the negative where it changed. So I have plus 8p plus p minus 3. Now I can rearrange my terms so that my like pieces are together. That would give me 4p squared plus 8p squared minus 3 plus 2p plus p plus 1 minus 2 minus 3. And I'll combine my like terms. And that will leave me with 12p squared minus 4. Now technically I had a 0p in there, but you just wouldn't write 0p, so you'd leave it off and you just have 12p squared minus 4. Okay. Alright, try this one on your own, see what you come up with, and then check your answer with mine. How's negative 6x squared plus 4x minus 2 sound? So notice that when I went ahead and dropped the parentheses at the beginning, that I just went ahead and wrote minus 4x squared plus x plus 3. I didn't worry about this plus sign right here. Okay? If you have plus a negative and you drop your parentheses, just go ahead and write the sign that's in front of the number rather than worrying about writing the addition sign as well. Here's another one for you to try. Remember, this time you have subtraction, so you got to worry about distributing. Oops. Here we go. Distribute that negative 1 first. Pause it, see what you come up with. Good job if you got 3x squared minus 15x plus 6. If you didn't quite get that, go back and see if you can find out where you made your mistake. Okay. Now this one deals with subtraction and addition. Remember again, you've got to take care of that subtraction before you can drop your parentheses. Notice that when I did this one, I distributed the negative 1 only to the middle set of parentheses because that was the only part that was being subtracted. Okay? And then I had like terms that I needed to combine, and I had 3 like terms of each type because when I rearranged the parentheses, I had 3 like terms of each type in each set of parentheses. Now at the bottom there, I ended up with 1x squared minus 2x plus 0, but I really don't need to write the 1 in front of the x squared, and I don't need to write the plus 0 at the end. So in my final answer, I just had x squared minus 2x. Nice job if that's what you got. Okay. So, how are polynomials similar to variable expressions? Well, in some cases, they're really the same. But remember that polynomials are going to have exponents that are integers. Okay, variable expressions don't always have exponents that are integers. Okay, and the main difference between addition and subtraction of polynomials is that with addition, you can go ahead and get to work right away, drop those parentheses, combine like terms. But with subtraction, remember, you have to distribute that -1 before you can do anything else. Okay? Let me know if you have any questions in class. Otherwise, nice job.